Our next keynote is held by Mr. Gunnar Hansen, who is Head of Hospital Business Sector Empathic Building of Haltian, and the headline is Time to Make Your Hospital Data-Driven. Gunnar Hansen, varsågod.
Tack ska du ha, and nice to meet you everybody. I'm sorry I have to do this in English as I'm located in Norway, southwest coast of Norway, working from Haltian from Norway. My presentation will be about empathic building, which was a startup from old Tieto times and now under umbrella of Haltian, where we have a method that we have been using for office environments for a lot of years already, and we have a mature solution which is already delivered to 20 plus countries. We are now taking this into the hospital sector. I'm heading this from Norway, and my background from 15 plus years working as biomedical engineer and working for and in hospitals has learned me a lot. And our system is, or our goal of this system is to help all the support functions function in a live hospital. And we hit a nerve with this system. In a bit under a year, we have onboarded digital twins to over 650,000 square meter hospitals, like the one you see on this picture from the University Hospital in Bodø. And we have been delivering this twin to help these hospitals to grow interest, to learn, and to mature into IoT solutions and visualization. I will show you some live examples, but the thing we do is that we start with this so-called digital twin. It's a really fast scalable twin. It's not a BIM, this is an end user interface where we start with the twin and then we enrich it with sensor devices. In Haltian, we have the Thingsy platform, which we have under our own umbrella, but we can also visualize sensor information from other sensor suppliers, as we currently do many places. We can do a lot of different use cases, and we are very often asked about the cost-benefit analysis. Of course, this is quite new to many of the hospitals, but my answer to that is that the benefit of this is, of course, the sum of all the small and big use cases we can solve. The picture you see here is from a sandbox solution in Bergen, where we were testing one on utilization of rooms. We are now also taking this into the clinic, and at the moment we are doing the very first indoor positioning, really accurate positioning system for emergency room in Norway, where we will do fully automatic contact tracing, also historical movement of which patient was where in contact with which employee and medical device. We can, of course, show you where the medical equipment is at all times, and we can learn a lot from this, from patient and employee flow, etc. We have a wayfinding system where we can also calculate time how long you use from a certain point to another, and the whole system is built to be integrated to whatever kind of system. So moving on to a bit more interesting topic, and I want to show you now a live example from the hospital in Kirkenes, Norway, where we have a lot of sensor devices already installed. This is a quite small hospital, but we have also done like Bodø, which is 85,000 square meter, and we have even done a campus site, which is over 130,000 square meter in Tromsø. So as you can see, we have a 3D model, and we have now started to enrich them with some information. So I will show you briefly some examples. you can see that these rooms have now blue and red color, and this is based on the occupancy in the room. So this is live right now. The red rooms are in use, and the blue rooms are not in use at this moment. We usually also integrate this to Outlook, and we show the bookings. We can also integrate to booking panels and visitor management systems, so you can increase the utilization. In this specific hospital, they have had a problem with too little space, especially for the meeting rooms, and they wanted to understand how much do we use the meeting rooms. So now we have some data, and I can take out a utilization report from these rooms, and we immediately see here that the utilization is 35%, so there should be enough space, but maybe they are working in a way where people are colliding with meetings at the same time. We can also see the pattern, which is very often very similar from week to week or month to month. And we can go into every certain room. This system is actually based on wireless Thing-C presence sensors and gateways which communicate to the mobile network. So we don't need to interfere with the hospital's Wi-Fi system at all, which is a benefit, of course. Moving into other subjects, we can also do, for instance, temperature measurements. And as you can see now, we have the heat map over the whole hospital, and we immediately see where we have problems. The green color is indicating normal temperature conditions. But if we look into this specific room, we see that there is challenges here with too high temperature. So to get an overview quite fast is very good with this system. We can also show, for instance, CO2 levels. And now I was lucky because there is ongoing now a patient investigation in this room, and we can see that the CO2 level has increased a lot. And this is a colonoscopy room, so most probably they are now using some gas during the investigation of the patient, and this leads to this really high CO2 levels. So data-driven decision-making is vital for this, of course. It can be when you are planning a new hospital, and I will show you one use case there. So I have checked in now at the main entrance, and I want to find a way to a certain department. So if I now search for this department, I will immediately find it, and the system will tell me where to go. So I can go through, I can even use the mobile phone for this, or we can give the patient the possibility to navigate. Behind this data, we also have the time consumption used to walk from this part from the main entrance down one floor and into this department. So typically when you are planning a new hospital, you want to understand the process. Most probably you don't have the same amount of rooms that you had in the old hospital, and how will this inflect the work process? So we can use this twin also to simulate information and give you the information you need to calm down the organization or how to work in the best possible way. Of course, we can also use this information of the usage of the rooms for the cleaning personnel to understand which rooms has been cleaned, has been used, and which has not been used. We have a possibility to count amount of people who has visited the toilets and do totally need-based cleaning. We can even do filling rate of the paper dispensers for the toilets, so we can notify the cleaning personnel, or they can have access to this data. So it doesn't make sense to go and check if the paper dispenser is full if you already know that that is the situation. Of course, back to this cost-benefit analysis from a hospital. it's the summary of everything. So I have one example linked to this indoor positioning system we have. We can do this with several different positioning systems. Many times like this emergency rooms now we are doing in Norway is done with Kupa. That is a really accurate system, down to 0.2 meters accuracy. But we can also do this with ultra-wideband systems, with ultrasound systems, or Wi-Fi, or whatever system you have. And there are benefits and disadvantages with all of these systems. If you have a positioning system, of course, then you can find where is the equipment and find this. But if you want to do this in a more even better way, it would be really good as a biomedical engineer to be able to push out information to a certain medical device that the nurse shouldn't use this equipment, or there is something wrong with it, or we need to get it back to maintenance. We are also working on a sensor device, which is a switch button for the hospital beds. So we can also show the status of different kind of equipment. Is this a hospital bed which is in use? Is cleaning needed, and what kind of cleaning is needed? Is it okay to clean the hospital bed in the patient room, or should it be brought down to the washing machine? So back to this so-called digital twin, I will encourage you to ask us and challenge us to do a twin of your hospital. The twin itself is really fast to build, and typically in a hospital you need to have kind of a sandbox to begin with to get familiar with the solution, and then we can exceed it from there. In Norway, I think every single hospital started as a sandbox, and many of them are now gone over to production. But you need to mature the maturity of the organization, and also the trust from people that what are we doing with this data? Is this secure for everybody, etc. If I now move over to another site, which is Hammerfest, I want to show you just briefly what we can do for booking system. So I have a live department here. We can see which rooms are in use. And this is a typical case that you have a multi-room for 3 different desks where people can just jump in and work. So we have a possibility to do a so-called easy booking of this desk. And I can reserve it immediately. And then it's shown for everybody that this desk is now reserved. We can also book other devices, like, for instance, these lockers, which I have here. So if you want to book this locker, you can reserve it. And let's say that we want to book this from let's see, from there, like that. Then it's much. This is actually a quite big challenge for a lot of the hospitals, that all the lockers are locked and nobody knows who is using it. So now you see that it turned red, and I can also see who has booked this locker. We could even do sensor devices into the lockers and do this totally activity based and show when was this locker in use the last time. Booking of rooms is the same kind of logics, and I can reserve it, and I can also free the room automatically if the room is booked and not in use. I want to show you a brief example of that. So if I now reserve this room, hopefully we will now see soon the booking appearing in the room. Based on this booking and the sensor device in the room, we will soon be able to see that the room is booked but not in use. So if you have a sensor device that shows you that the room is booked and not in use, then we have a possibility to automatically unbook the room. So now we see the situation, it's booked and it's not in use. That's why it's yellow. So using this system, we have an example in Norway recently for an office where we did this for a really big office with 1,600 employees, and they only have 850 desks for all of those 1,600 employees. So this is the strength of the system. The maturity is there, and please contact us if you want to learn more or even to see more practical examples from this. So this was briefly what I wanted to share, and we are now building up a user group for the hospitals. We want the hospitals to learn from each other, and I think that we have quite a nice base now to be actively doing this, but we want to build a system which fits for all and not only for this Norwegian hospital. So we are, of course, talking to and interested in doing this all over the place. So thank you for your time, and please come back to us. To my email address is inside this slide. So Gunnar Hansen @haltian.com. Thank you.
One question for you. It's sent by Paul, and it is: how do you measure occupancy in a space?
Occupancy is the most valuable and at the same time the easiest thing we can do. We do this from a wireless sensor which you just stitch to the roof, and we use a wireless gateway. So that is set up in 2 minutes for a room.
Gunnar Hansen, thank you very much for this keynote. Thank you.
Thank you.
Ja me jatkamme ihan hetkisen kuluttua seuraavalla keynote-aiheella.